Hello everyone, I'm Xiao Gang. Okay, in this moment, we'll write our task. First, we define the structures and enums we need. We don't need to expose them to Blueprint. It's just an internal computation mechanism at the C++ level. We'll write it here. We didn't create a separate type. I'll just rely on it, but we need to change the name. Let's change the name. Our first name describes the state of the enum. The meaning of long is initialization is still in progress. And they seek to fail actually means it has completed execution. This long means there is no result yet. It's still being executed. Then we'll manage this task. This is our A1A. Let's take a look at it. Same state as A1, A2, A3, and this is actually our A state. So long has just finished initialization. And as for this state, this task has already been completed. It's the internal one. And this task failed. This task is still there. This managed task is still being worked on. That means its tasks are not yet completed. And this max is just a reserve field. Now let's define the simplest task. Then we swap it. This should be relatively simple. We love to tell everyone. Then we change the name. It should be Flowers Manager Task Status. And as for this name, we should call it FControlFlowTask. Okay. Then here is its constructor function. When we construct it, we let it perform a simple initialization like this. We initialize its state to a long state like this. Then here is its system function. We don't care about it. This is just for recording information. And this message, actually, we can give it a launch. There may be no information. Then if it succeeds, it may carry some information. Or failure may carry information. We just ignore it. So this is a marker for one of our tasks. Then we write a manage task. Manage task. It will be a bit more complex because it needs to contain many of these tasks. Let's see. Its name should be manage task. And of course, it is also this. System our t-shirt from this. Okay, let's continue looking down here. And here, it's quite obvious. Now we define what data it has, right? So first of all, it definitely has its own manage task ID. And at the same time, it has its own enumerated state. That is, what kind of state this manage task is in. And of course, it has a piece of information. That is a description of this entire piece of information, right? Of course, this information is based on your actual needs to do a simple design. No problem. Then it generally needs to have a subtask. This task should be, this number should be greater than or equal to 1. Right. And at the same time, there is a tray to record these actual tasks. Since these tasks may not be added from the very beginning, they might be added dynamically. Such a task, so we need to calibrate from the start exactly how many there are, so that a correct retrieval can be performed. Because this thing might be added dynamically, and this needs to be set up from the beginning. Then here, we need a meter delegate. When this task is completed, we need a delegate to execute. So we define a delegate like this. Okay, we define this delegate. It is the callback for a managing task completion. Okay, we need to change this name. We add a control flows. Okay, just add a boolean with some information. Then here we paste it over. Then as for the name, actually, we just call it manage nested response. Okay, then we also need a method that allows it to update itself. We could of course use tick, but we don't want to use tick. We write a method to update this current state, and for this state, we can put the enum here. Okay, as for the contents of the state, let's not write them for now. Let's just have it silently return that the current task has already succeeded, because the stuff inside here needs to... I'll write it for everyone when I explain, but it's not a problem. Okay, so basically our data structure here has been defined for everyone. Okay, Then, now we'll embed the code and write it. So where do we write it? Right. Actually, I could paste all the code at once. But there's no need. Don't do it that way. We'll do it step by step. Our first step is to define the data structure. Then we need to make some changes here. We can't do it this way anymore. So how do we do it? Well, it's actually quite simple. I'll just delete this part first. Pay attention. What's the progress update here for? Let's just ignore it for now. Now we start launching a large number of one-time tasks. Okay, let's do task A. Then here, first we create a management task. Now we declare a management task. Let me write down the process for you. Declare a management task. Okay. We declare it using the MakeShare method. Oh, the struct that manages tasks is this one. Okay, after we declare this management task, we give this management task a quantity. Our task number. We give it 10. That's our A. Physiological manager. And this is the subtask. There are 10. Okay, now we go ahead and add these 10. Before adding, let's first register this management task on our main thread. That is, we first bind the completion callback. Bind the management task completion callback. As for the completion callback of this management task, we bind it like this. We can get our manage. Let's take a look. It should be manage. Let's click over here and check again. It should be this one. This callback hasn't been declared here yet. This part is written incorrectly. This part is misplaced. Excuse me. It should be this place. This is for managing tasks. Return home should be placed here. And this place is for checking the status of the managed tasks. As for this enum, it's not that enum of his. The place was written incorrectly. Okay. It should be like this. Okay. Everyone, please pay attention. This place refers to tasks. Referring to tasks only has these things. Then the task manager will check the task status. And here we paste it over. Okay, here we let it bind. This is a multi. For the multi-wave, we bind the lambda to it. We use the add method. And for this lambda, we need to define the lambda like this. It must be consistent with our function signature. Obviously, for our function signature, first of all, it must be a bool, and this message here, because the function signature is exactly this, its function signature is a bool and a string. Okay, here we need to copy this subflow over. After copying it over, we do it here. This is after managing the task execution. It has been done, and then here, we must execute it on the main thread. This must be on the main thread. Then the corresponding task here is actually equivalent to A1 through A10, all being completed. And now, returning to the ABC stage, we determine whether to execute B theory, whether it succeeded or failed. Here we can print a log. That is, we determine whether this result succeeded or failed. If the reason for survival generation is what? We can print a log here. And then we can write it like this here, like this. Okay, if he succeeds, actually we just do it this way. If this task succeeds, obviously we just follow our previous approach. Just use control flow. And at the same time we broadcast this part. Broadcast the precision of this progress. This part is not copied, right? So we might need to copy this delegate. Actually, it's better to write a method like this. We still write it in the form of a method. We write two methods. As for these two methods, we write it like this. It is void, protected, because we only use it internally. Progress. This part is called without. This part is calendar progress. And obviously the function signature must also match. The function signature is here. We need to delete the comma here. Okay, then with that, we created the implementation. How should we write it here? Here we drag 1 over. Let's touch on this, like this. These are all relatively repetitive code. We are using can't read, then we don't need this here. We don't need these either. Actually, it only needs this character and this character. And here, we can do this with the proxy. Let's write it like this. Dem equals this proxy. Then here we copy it. Here, alright, copy this delegate. We just need to broadcast this result. This continue flow is not needed. We are just calling the front end like this. Expose this front end, and this place is the same. We just need to paste the code. This delegate pattern here, we need to change it. This is the result delegate pattern. Here, capture this information. And when this delegate executes, its type is different. So this needs to be considered. This part is easy to get wrong, because I've gotten it wrong many times. So I'm quite clear about it. I won't get it wrong. I also know why. And if you feel like this won't compile, if it won't compile, you can check the code. Let's compile it now. It should be fine. Okay, this part is because we need to add a mark. This way, it won't affect our member variables. There is an except in our member variable here. This avoids conflicts. There might be unfinished package searching below. Let's change this part. If we update the progress here, we will use this method to update it. Call init progress to update it this way. Then we pass in 2 progress values. These 2 progress values are respectively this one, progress value, and the progress here, in order to place it in this position. Okay? But there is still one ID missing here. Let me check. We need to capture this here. Okay. So this should be fine now. Then here, we need continue flow. Yes, we do. We need to add a semicolon here. Okay, let's quickly compile it first. I'm a bit worried that it might fail to compile. By the time you all watch this video, it might be a bit troublesome. The compilation is fine. If your compilation fails, jot those few places we just mentioned. Has it been changed? So if this part fails, we can just cancel it directly. Then here, we just need to call the reason for the failure. If there is a failure here, let's find it. It should be here. Then we pass this result into it. Then pass this reason into it. Okay, if this part fails, if for task A fail, we will let it cancel the flow and then directly execute this callback. Our progress no longer needs to be updated. So this is after task A is completed. If it succeeds, if there is still something left, it will continue to move forward. If it fails, it will directly return to the UI. So this is task A. Then the management task is done. We haven't added these 10 tasks yet. Next, we will add these tasks for everyone. This task, note that it is a pointer. It is a pointer. So actually here, we need a container to protect it. We should write it like this. Add to the listener list. Manage task listener list. Okay, the management task here, we'll write it here. It's protected. It's actually quite easy to write. We'll use tmap because sometimes we might need to remove items. That would be fguide. And for the previous one, we'll use a smart pointer. Yes. It should be it. Okay, then we'll call it manage a list. And then, yes, we'll call it manage list. And this manage list, we'll put it here. We'll add it in. Just add it in. Add it in here. Let's see, there's a letter K here. So for this K character, actually, when we add it, we just need to give it its ID. And add it in, we just let the K character directly access its ID. Yes. Then put it in here. There is absolutely no problem here. Then we go ahead and start instantiating our subtask. Inpoint subtask. Okay, then we make a for loop here. Simple. Then we use a 10. Okay, let's just use I. Keep it simple. But sometimes I like to use index. Here, we create this subtask. So this subtask is actually here. This subtask, okay, here. This is our specific task. After this task is added, we definitely need to add it to our task management. So obviously here we have a signal. We access its task. Then we just add it in because we are all about intelligent responsibility. So this part can be done like this. So it's not a big problem. Then it essentially adds this task. Now we are going to write this subtask. So write this subtask. We'll make this subtask a bit simpler. Let's first give this. That is, we define the success of the subtask. Let's simulate first. We consider it to be successful. This one cannot be successful. If this I equals 6, we will, in the case where I equals 6, we have this one here, right? We can use this red to control it right here. What is this red? It defines our success or failure. Let's first make it success. If it is successful, this B, succeed, we still write it as 6 equals Q. If it fails, obviously this B succeed. We will change it to false. We only do this for the 6th task. Actually, comparing the 6th, this is precisely called the 7th task. It should be 0. It just means the task where we say I equals 6. We are now starting to declare the execution framework for the task. Okay. So actually, we can write it like this here. We use exec test here. Then we apply for our ready-made resources. Because we only have 10 tasks here, which is still relatively few. It should actually be fine if we use more. Then we have a so large here. It can be done like this. Then this part here is equivalent to, actually, you can use a sign here. It depends on your task requirements. It depends on whether your task volume is large or not. If your workload is particularly heavy, especially if the time is relatively long, don't do it this way. Then we need to capture these variables. We need to capture whether this is successful. And for the current task, we need to capture the ID of the current task. So we just write it out like this. This ID should be equal to it, because this thing only exists after instantiation, you see. And this ID cannot be changed, because it actually serves as one of our identifiers. This ID cannot be changed. It is instantiated in the constructor. Instantiated, we need to capture this ID. And at the same time, we need to capture this I. We need to use this I to perform a processing of the remaining sleep time. So here, we'll just make it sleep directly. We'll take this I and apply it to this place. We'll just take this I modulo 3. Modulo 3. This sleep time is actually not quite the same. Then, at this point, we are now assuming that this task has been completed. How did this successful result come about? Let's write another one here. Suppose makes it clearer this way. It's this task. Must write it. Let's set it equal to this B. Success, whether it succeeded. Also, we can actually record the time here. As for the time, we give it this message, information, task message. Let's have it record the time it completed. Let's just do it like this. Get our current time. Everyone should be very familiar with this class. This place can go to HTTP for the state of 2xTTP. So we already have this completion results and time. After that, we refresh the state of our main thread. Now from A1. Now from a 1 to it should be like now from the thread. In the word, the A1 task to the main thread. Main thread ABCD. Right, so how do we go back? Actually, it's very easy for us to go back. XOR lm. Here we use a gamma string. Then regarding this part, we also need to capture these resources. Obviously, we always need this task key. Then here we need to capture the result of its execution. And the information after it finishes executing. Okay. Then, for this part, we need to set this up properly. Pay attention to the hierarchical structure here. Then we now need to follow up on our monitoring list. That is, we now need to search within all our task pools for this thing. So we should have a method to do this. You see, that is, we now need to iterate through and search within this pool, refresh it. So let's write this method. We call it update to refresh the animal status. That's right. Then refresh the animal status. We call it update task status, and its parameters are actually a tasked and whether it succeeded. And also a message. Okay, we don't have this method yet. So basically that's it. And now we still have one more. This method hasn't been written yet either. We'll write it in the next lesson. Its execution framework is roughly like this. We set up the callback for the completion of this management task. And then set up the callback for the subtask. The subtask will call back this method. Then when refreshing the status of the subtask, it will also check this management task. That is, whether the management task has finished executing. If the management task has finished executing, it will trigger this callback. So this part is a bit convoluted. It's equivalent to having a judgment. At ABC, your A1 will access ABC, A2 will access ABC, A3 will access ABC. Every time they access ABC, they will refresh the state inside ABC. As long as you refresh to task A, all its subtasks have a task number. At the task number field, when the task number of all subtasks completely matches the task array inside it, exactly, then it will trigger the callback. So this method is used to call back ABC. And the delegate here should actually be triggered at this point. Yes, okay. So in the next episode, we will write these two very important functions for everyone.